A pediatric nurse notices that her patients have a linear relationship between their age, which is represented by A in years, and their heights, which is represented by H in inches. So this problem asks us to interpret the slope of this equation, H equals 2.5A plus 30. So first, let's identify what is the slope. This is in y equals mx plus b form. So the slope is going to be right here, the 2.5. You can kind of compare it to slope-intercept form, y equals mx plus b. Even though we're using different variables, it's still in the same slope-intercept form. So the 2.5 is our slope. So what does the 2.5 mean? Well, let's play around a little bit with some numbers and see if we can kind of figure out what patterns are happening here. Let's look at a patient that is 1 year old. So at age 1, what will their height be? Well, let's plug in a 1 for A, since A represents the age in years. So we would do 2.5 times 1 plus 30, which is 32.5. So it looks like a 1 year old on average is 32.5 inches tall. Okay, what about at age 2? What happens there? The height there we can find by putting in a 2 for years. And we will do 2.5 times 2, which is 5, plus 30, which is 35. So the average 2-year-old is about 35 inches tall. Let's do one more just to see if we can see some patterns emerging here. At age 3, the height, let's plug in a 3 for the age. And we're going to do 2.5 times 3 plus 30, which gives us 37.5. And we could keep going, but I think I see some patterns starting to emerge here. If you notice, from age 1 to 2, their height gained 2.5 inches. From age 2 to 3, their height gained 2.5 inches. And I think we would continue seeing that pattern if we continued calculating more ages. And the reason why is, notice what our slope is. It's 2.5. So we can say our slope represents the amount of height in inches gained per year of age. So as the child grows and gains a year of age, they will on average gain 2.5 inches of height as well.